caught me with my mouth full. I was drinking my coffee. Welcome to AP Computer Science A Live. This is day 5 of String Week. My name is Rob Schultz, and I teach at Bellbrook High School in Bellbrook, Ohio.
And I'm Jill Westerlund from Hoover High School in Hoover, Alabama. We're so glad that you're with us today. We are going to be finishing up String Week, but we will not be through with strings because they're going to keep coming back again and again and popping up in free response. So we're glad that everybody's with us. We hope that this will kick off your weekend in a good fashion. So quickly about our exam, you're going to have 2 questions. The first one will either be arrays or array list. And I told you yesterday that if this were like an Oreo cookie, we've had the chocolate cookie of array, and we're in the white filling of strings right in the middle, and we're getting to array list next week. And that was prophetic because last night we went and got a blizzard with Oreos in it. So I don't know where that came from, but it just worked into the talk yesterday, and then it got in my brain. So that'll be your test, question 1. And then question 2, which is worth 35%, you'll have a little less time. We'll have methods and control structures. And you'll be using methods and control structures in question 1 as well. So you're not going to get away from those on either question. And the test date is May the 15th. And then you see the makeup day if you have an extenuating circumstance. And all the information is at AP Central. So avail yourself of making good use of the materials that are provided there. So we got some good feedback yesterday in our 2-bits bag, and this one is about can I use string.contains in code word checker? And string.contains is a lot similar to, well, I don't know. Mr. Schultz, you speak, because
yeah, you could definitely use contains. I mean, you could find a way to do it. Contains will tell you whether or not one string contains another string. But what you have to be careful about is the way it's presented here. It looks as if contains is a static method, which means you would reference it directly from the string class, and that's not how it's used. It works kind of similar to what we're going to see today with compare to. I have to give it a specific string, you know, my string dot contains your string or something like that, and then it'll return the result based on whether or not the one string is actually contained within the other string. But you have to specify 2 specific strings, you know, string dot contains a separate string, you know, a declared string dot contains a string parameter. So
yeah, I think the key is if you know how to do it well, you can do it.
Yeah.
You know,
but again, my caution would be careful about using things outside the subset, because if you do something outside the subset and you make a mistake, it could cost you multiple points on the rubric. Whereas most of the things on the rubric are designed to cost you a specific point. If you do something within the subset incorrectly, it might be a point, maybe 2. But you always kind of once you go outside the waters of the AP subset, you're kind of risking losing multiple points if you do something incorrectly. So if you do it correctly, you're fine. Okay, and then we had a second email.
Yeah, this has like extra email too from Olivia in Connecticut, and you can see there I put her whole note here because she's going to Carnegie Mellon. So
congratulations.
I know, yay, Olivia, and any of the rest of you
science,
going to Carnegie Mellon, look up Andy Kong. He's a student of mine who's there now. He'll be like, what? Jill told me? Jill told you to find me? But he's a super fun guy, and he'll probably be a junior next year. And so many great professors at Carnegie Mellon that are involved in the CSP program, Dr. Tom Cortina, and then CSA, Dr. Mark Stalick. I think he might be an emeritus now, but you probably know him, Rob, from the reading. But so fantastic. So Olivia coded up her own version of Spiel of Fortune yesterday, and I thought it was different than Mr. Schultz's version, and so that's partly why we got a couple of things of her code. I love this part where she made 3 different arrays to let the user choose an easy, medium, or a hard version. So this is another way to, you know, put your own spin on your project. And then here's how it kind of worked. Math.random is pulling a word from her word list. So be inspired by what Olivia did, be inspired by what Mr. Schultz did, and start implementing your own projects to use these methods that we're talking about.
Yeah.
Like I said yesterday, don't be bored. Be inspired to learn more Java during these days.
Yeah,
You
and
see
to
two
Olivia,
lowercase happening down there. It's great.
yeah. So, and to Olivia, this is impressive code. Keep it up, and
Mm-hmm.
good luck. Good luck next year
Yeah,
at
yeah.
Carnegie Mellon. I hope you have a great freshman year. And
Yep.
I got to tell you, as a math and computer science teacher, I approve of your double major. So.
Very good. Today we are, like we say, finishing string week. We're really spending time today. Mr. Schultz is going to teach you about compare to and about equals, how they function differently and they have to be used differently. And along that vein, from Tuesday's lesson, these were my notes that I showed you on Tuesday and I walked you through, and I think you hit one more time. This is a zoom in on my little, you know, put it in English, Jill version of dot equals and dot compare to. This will be just a launching pad for today's lesson in terms of how Mr. Schultz is going to break it down for you. And if you hit one more time, there's another page of notes, and this is all in y'all's journal notes folder. This was just as I was reading and looking, this would have been last weekend, and refreshing my own memory. These are not perfect, pretty notes, but they're the notes I took when I was reading various textbooks and trying to make specific points about how compare to and dot equal work. So look for these in y'all's folder. Take your own notes. I will probably be taking more notes today while Mr. Schultz is teaching the lesson, and I'll share them if I do. So here we go with warm up, finishing
Okay.
delimiters.
Yeah. So if you recall, yesterday we started the current phrase question, the question number 3 from 2017. And as we originally started looking through the question, we saw that they're giving us a private string instance variable current phrase and a constructor. And then they give us this extra method that we don't really know what the implementation is, but it's this find int occurrence, where all we know about it is that it returns the nth index. I'm sorry, it returns the index of the nth occurrence of str in the current phrase. So, and if it doesn't find it, it'll return -1. So again, like I said yesterday, anytime you have an extra method in there, that's a pretty good immediate red flag that they're telling you, okay, we're giving you this as a tool, you have to use it somewhere. Yesterday we did the replace nth occurrence method. So if you missed yesterday, take advantage of the fact that these are recorded lessons and go back and watch that one. But today we're going to focus specifically on just the solution to the find last occurrence method. So the idea of this one is that we're given a string str and we're supposed to find the last occurrence of that in our current phrase. Okay, so kind of again staying with the theme that we've been talking about, treating this as we would a free response question. The first thing I did was I kind of laid out what my design would look like. So to start, we have to keep track of occurrences. We want to find the first occurrence and then the second occurrence, third occurrence. So I have a little variable to keep track of the fact we're looking at the first occurrence. And then if you kind of think logically about how this problem is going to work, we need to return the result of calling find nth occurrence. So in this case, it's going to return the result of finding the first occurrence, and it's either there or it's not. So it's either going to give us a location or it's going to give us -1 if it doesn't find it. But the problem with this is I don't necessarily want the first occurrence. I want the last occurrence, which means we need to know if there's a second or a third or a fourth or a fifth. So the way I kind of think of this one when I'm working through this with my students, it's kind of like I'm reading a book, but I'm going to kind of peek ahead at the next chapter because I just can't wait to find out if the butler did it. Okay, so with this one, we're going to assume we're looking at n equals 1, the first occurrence, but I'm going to kind of peek ahead a little bit and say, hey, is there a second occurrence? Because if there is, then we want to find the second occurrence. And if there's a second occurrence, is there a third occurrence? Because if there is, we want to find the third occurrence. So we've got this little while loop thrown in here that says while there's another occurrence beyond n, well, then we're going to add 1 to n so that we can make sure that that's the one that we're looking for at the end. Okay, so here's how the code for this one actually looks. And again, kind of using this as a roadmap, we're going to create our method header because, again, this has to be proper Java code. We're going to say int n equals 1. Here's our little while loop. So if find nth occurrence of str of n plus 1 is not equal to -1, in other words, there exists another occurrence, then we're going to go ahead and add that value to n so that once I come down here, now I'm going to be looking for whatever the last occurrence is. So if I set n equal to 1, we're going to say, well, okay, if there's a second occurrence, set n equal to 2. And then if there's a third occurrence, set n equal to 3. And if there's a fourth occurrence, set n equal to 4. And as soon as we get to the point where this returns -1 and we find out, okay, there is no fifth occurrence, for example, well, by then n is set to 4. So I'll come down and I'll return the location of the fourth occurrence. And there you go. There's our solution. The one thing I wanted to point out about this one is I know this is string week and we've been focused on strings, and this part of the problem really doesn't have anything to do specifically with string methods. But remember that second question that we're trying to prep for this year's AP exam is methods and control structures. And if you look at this specific solution, this is methods and control structures. That's, this is a good example of a type of question you might see in that methods and control structures question. So I thought this was still a good one to leave in, even though it doesn't specifically have anything to do with string methods or things like that. So yeah, how to do. Make sure you have an opportunity, if you can, to go out and check the canonical solution. Make sure you're looking at the website. Just do a quick Google search for AP Computer Science A exam, and then you can scroll down and find all of the past free response questions and canonicals and scoring guidelines and all that good stuff. So, okay, now we get to the good stuff. So today, we're going to focus on looking at the big difference between equal, equal, and dot equals. And I can tell you in my own classroom, every year, my students have a hard time remembering that dot equals and equal equals do totally different things for strings, okay? And we're also going to look at the compare to method, and we're going to look at the fact that it tells us more than whether or not simply two string objects are the same. It gives us more information than that. So some prior knowledge that might be helpful is data types in Java, how to create strings, and if you've had some exposure to equals and compare to, that might be helpful as well. But if not, we're going to go over them today, okay? So we're going to start with a little bit of quick review. Okay, we're going to go all the way back, and this is something that would probably be covered. I know every teacher teaches a little bit differently. In my class, this is probably going to be even during the first week or 2 weeks of the year, okay, of maybe my intro class, or if you're in a class where you don't have a prerequisite intro course, this might be the first few days of your AP Computer Science A. But when I go through primitive data types with my students, I tell my students to think of each primitive data type as a bucket that we put things into, okay? So for example, when I create an int, when I declare an int, I get an int bucket, and an int bucket is 32 bits. It has a size. When we do a double is a 64-bit bucket. So now I've got a 32-bit bucket, a 64-bit bucket, and I can even demonstrate, if I have, different size buckets, that I can pour an int into a double, but I can't pour a double back into an int and all that good stuff. And we have a Boolean bucket. So these are the 3 primitive data types that are specifically part of the AP subset. And I put a little asterisk beside 1 bit because it was pointed out to me, or I was reminded by a good friend, that a Boolean, it represents 1 bit of information, but it isn't necessarily being stored as 1 bit. So that's from the Oracle website. So I threw that in just as a little caveat, that a Boolean isn't necessarily stored as 1 bit of memory, but it represents a bit. It's either a 0 or a 1, okay? So the reason this is important is we need to talk a little bit about what happens when I declare and initialize primitive data type, so that we understand what happens kind of behind the scenes when we get to strings. So, so if I declare 2 variables, int my age and int your age, then I get 2 int buckets, 2 int sized buckets, one of them labeled my age and one labeled your age. And now when I initialize those and say my age equals 50, a 50 goes into that bucket. And if I say your age equals 51, then a 51 goes into the your age bucket. Okay, so primitive data types are different than objects. Primitive data types are nothing more than just a bucket that I can put things in and take things out. They don't have methods. I can't tell my age to tell me its length or anything like that. I mean, it's just strictly a bucket that I put things in, take things out. When I use equal equal and I do a Boolean comparison of my age and your age, it's basically saying, do the 2 buckets contain the same value? Okay, and it's important that we kind of think of it that way, because that's a false statement. I can say right now that my 2 buckets contain different values. Okay, now you're probably wondering, what does this have to do with strings? We're going to get to that next, but I want you to remember this question that I've got up here in red. Do the 2 buckets contain the same value when you see equal equal? Because that's really what it's asking when I'm doing equal equal comparing primitive data types. okay? Let's jump ahead to strings. So here's what you need to know, okay? Let's say that I create 2 string literals. One of them is just going to be a single character. So string S1 equals the character A. For string, whoops, I jumped ahead too far there. Okay, for string 2, I've got the entire first paragraph from the CED for Unit 2, using objects, developing understanding. Okay, so I know that my slides are acting really goofy today. So I know that fact 1, a single character is 8 bits. Okay, so a single character is 1 byte. And this was, if you were tuned in Wednesday, we were talking, this was our fun fact of the day because I had just researched it for this slide. The maximum string length that I can create is 2 to the 31st power minus 1, which is just about 2.15 billion characters. Okay, so I can make strings that are either small, 1 character, or ginormous. So the big question that comes up in my own class, how big is a string bucket? You know, an int we said is 32 bits or 4 bytes. We said that a double is 64 bits. So how big does a string bucket have to be big enough to accommodate 2.147 billion, I mean, whatever it is, characters? Well, the trick behind this is we don't create a bucket big enough to contain the entire string. When we declare a string variable, what we're actually doing is we're creating a reference variable, okay? And here's what I mean by reference variable. When I declare string S1, there we go, I get a bucket that doesn't necessarily have to contain the string. It just has to contain a memory address that's going to tell me where that string is. Okay, so if I say string S1, we get a string reference bucket. If I say string S2, I get a second string reference bucket. And it doesn't matter whether my string is 1 character or 1 billion characters, I get the same size bucket, because what happens is now when I say S1 equals A is put into memory in a special area of memory, and it gets an address, and then that address is what goes into the bucket. When I say S2 equals the entire first paragraph of the section that I picked from the CED, okay, all of that is put into memory. It's put into a specific space in memory. It has an address. And by the way, I totally made these addresses up, okay? There's nothing magic about these addresses. But then the address, the reference, the variable contains a reference to the address where that string is stored, okay? So that way I never have to worry about making a bucket big enough for a string. By default, a string reference bucket, a variable, is going to be big enough to contain an address. And this is actually one of the little essential knowledge pieces from the CED. If you go back to where you can find var-1.d.1, the memory associated with a variable of a reference type, so you know strings are reference types, holds an object reference value, or if there's no object, null. And you know, I probably should have, when I made this slide, I probably should have set it up so that when I first did string S1, it would have shown null. I mean, that's kind of an afterthought. I might have to fix that for the next time I use these, because at that point, it's a null reference. There's nothing actually in there yet. So if I tried to do something with S1, you know, S1.length, S1.substring, I would get a null pointer exception, because this doesn't have an actual address that points to anything. It's null at that point. It's not until I actually initialize the variable to something where an address goes in that refers to a place in memory where that object would be. And remember, strings are objects. So anyway, back to the definition up here. This value is the memory address of the referenced object. So that's one of our little essential knowledge pieces, okay? So so you're probably still thinking, okay, I thought we were looking at equal, and dot equals and compare to. Okay, well, bear with me. We're going to get there. We've got one more piece that I want to make before we make the jump to equal, and dot equal. Okay. On Monday, Mrs. Westerlin referred to the string pool when she talked about string literals and string objects and the difference between them. So I want to show you one more little example here. Let's say I say string S1 equals bow. Okay, and if you remember back when we talked about this on Monday, we said that bow actually goes into the string pool and is given an address. So I guess I'm jumping ahead on my slides here. First thing that happens is we declare a reference variable to store the reference to where bow will be. Bow is put into the string pool with an address, and then the bucket that contains the reference to S1 has the variable, or has the address that points to bow. Okay. If I say string S2 equals JJ, we're going to get an S2 bucket that's a string reference. JJ will be added to the string pool, and the address where JJ is located is put into the S2 bucket. So this is kind of the cool, but sometimes I'm going to say aggravating part, because sometimes it's really helpful and sometimes it gets confusing. If I say string S3 equals bow, Java is going to look at this and say, well, okay, bow is already in the string pool, so we don't need to take up more memory by adding another occurrence of bow in the string pool. We're just going to create a bucket that has the same address. So now I've got S1 that points to this memory address where bow is located in the string pool. I've got S3 that also points to the memory address where bow is located. So we kind of optimize things just a little bit automatically. I mean, Java handles string objects a little bit different in that specific way. I'm going to move my little window out of the way here. There we go. Okay, so now I'm going to add one more. Let's say I say string S4 equals new string object bow. So now what I'm telling Java that I want to do is I want to create a totally separate string object with bow as the string, but I do not want it in the string pool. I want it to be a totally new string object. So first thing that happens is we declare a reference variable. We allocate a different area of memory specifically for this new string object for bow, and then this is the address that goes in the bucket. Okay, now that was all build up to what comes next. This is where we start getting into the equal versus dot equals part. Okay, let's say that I ask you what's going to be the result of this Boolean comparison, S1 equal S3. And hopefully you're looking at this going, well, obviously that's true. S1 is bow and S3 is bow. What I have to remind my students of sometimes, and I actually use this quote, one of my favorite movie quotes is from The Princess Bride, where Inigo Montoya says, "You keep using that word. I don't think it means what you think that it means." In most cases, when students use this with strings, they're using a word that it doesn't mean what they think that it means, because we're not asking if these two strings are the same. Remember what we're asking when we use equal from a couple seconds ago. We're asking, do the two buckets contain the same value? And in this case, S1 and S3 contain the same value. We don't know anything about the string that they're pointing us to. All we know is that both buckets have the same value in them. Okay, so it's kind of yes, because both of these are saying that they're referring to the same word and therefore they have to be the same. But we're not really asking the question that we think we're asking. We're not asking if the strings are the same. We're asking if both of the reference variables are pointing at the same string. And there's a difference. Okay, there's a big difference, because if I do this and say S1 equal S4, well, now I've got S1 has bow and S4 has bow, but do the two buckets actually contain the same value? And in this case, S1 and S4, even though they're the same string, they don't have the same value in the bucket. So this is actually going to evaluate to false. So it's common when I start doing string projects with my students, especially if they're review projects, and maybe it's been a little while since we've talked about strings and dot equals. I'll have students that'll raise their hand and say, yeah, there's something wrong with my program, because I've got S1 equals Bob and S2 equals Bob, and I'm asking if they're the same, and it's telling me no, they're not the same. Well, it's because they're using equal, and it's that issue of, well, you keep using that word. I don't think it means what you think that it means. Okay, we're not asking if the strings are the same. We're asking if the buckets contain the same objects. So if I want to really find out if string S1 is the same as string S4, this is where we have to start looking at dot equals. Okay, because dot equals asks a totally different question. Dot equals asks, is the string object referred to by S1 identical to the string object referred to by S4? And when you think about it, that's a totally different question than just asking if the two buckets contain the same value. So what dot equals is going to do, dot equals is going to check each individual character to make sure that I have identical strings. So I have a capital B and a capital B, lowercase e, lowercase e, lowercase a, lowercase a, lowercase u, and then it's going to say, yep, that's a true statement. These are identical strings. So dot equals actually looks at the strings and makes sure that the contents of the objects, that the objects referred to by the reference variables, it makes sure they're identical. So that's the big difference between equal and dot equal. Okay, it was a big buildup to get to that point, but we have to kind of understand what's going on behind the scenes when we declare variables to know why equal and dot equals do totally different things. Okay. All right, so let's look at compare to a little bit. How are we doing time-wise? We're doing good. Okay, so I have 4 string literals that I've declared. We've got S1 equals Finnegan, S2 equals Casey, S3 equals Mitten, and S4 equals Tootsie. And you're going to meet Finnegan, Casey, Mitten, and Tootsie here in a little bit when we get to our picture section. But let's say I want to look at S1 dot compare to S4. Okay, I'm going to compare Finnegan to Tootsie. Okay, well, like I said, compare to gives us a little more information than just telling us whether or not 2 strings are the same. If I use dot equals, it's true or false. Either they're the same or they're not. Okay, but compare to gives me a little more than that. And notice I've kind of color coded these so I can help explain a little better. The first thing you have to keep in mind with compare to is that it's going to give us an integer value. So we have to kind of think about where that integer value is coming from. And I put a little link up here to the top. If you do a Google search for just ASCII table, this is one of the first ones that come up that will come up. And it's showing us the ASCII table of characters so that as I look at the letters in the alphabet, what this is telling me is that every character we've got, and you can scroll through and look there, capital letters, lowercase letters, numbers, all of the special characters, $sign and %, all that good stuff. Every character is assigned a decimal value. And I didn't catch the headers across the top, I should have. But what this is telling me is that for the letter A, for example, lowercase a, it has a decimal value of 97. And then this particular table is also showing me the octal, the hexadecimal, and the binary values. So if you were to convert 97 to octal, it would be 141, and 97 to hexadecimal. Okay, none of that is really important. None of that is part of the AP subset. The part I wanted to focus on was just the decimal piece over here. So, so the first thing that happens is I'm going to look at the 2 strings that I'm comparing, and it's going to grab the first character of each. So again, I'm kind of keeping things color coded. So S1, everything in green refers to S1, the actual string that I'm using, and anything that's red is the parameter string. It's the string that's being passed in for the comparison. Okay, so over on my ASCII table, F has a decimal value, an ASCII value of 102, and T has an ASCII value of 116. So when compare to looks at these values to figure out what the response is going to be, it takes the string value and it subtracts the value that's associated with the parameter string, the value that's passed into compare. So in this case, I would get 102 minus 116, and this is actually going to return the value -14. Now, I'm going to pause here for a second because you're probably looking at this going, man, how am I ever going to remember all that stuff? Okay. You aren't responsible for knowing the ASCII table. You aren't responsible for knowing exactly what the value is that compare to will return. The only thing you have to know about compare to is that it's going to return a negative number if the alphabetic value, if the string for S1 alphabetically comes before the parameter string that's being passed in. If alphabetically S1 comes before S4, it's going to give you a negative value. So all you have to know is that if S1 comes alphabetically before S4, it's going to give you a value less than 0. If I were to switch this and do S4 dot compare to S1, so now I'm comparing Tootsie to Finnegan. Okay, it's still going to do all the same things. It's still going to identify the ASCII value for T, the ASCII value for F, but remember, it takes the original string value minus the parameter string value. So I'm going to get 116 minus 102, and in this case, it's going to be +14. So all I would have to know about this one is that because T comes after F in the alphabet, it's going to return a value greater than 0. Okay, I want to do a little extra detail to kind of show you where those values are coming from. I know that when I give just kind of the general negative or positive, students immediately say, okay, well, why 14? Why -14? Why 12? You know, why -8? So where is it coming up with those numbers? So it's kind of easier to remember if you kind of understand where it's pulling those values from. Okay, but again, you don't necessarily have to worry about what the specific number is going to be. Really, as far as you need to worry about for the AP subset is just whether or not it's going to return a negative value or a positive value. Okay, the one other thing I wanted to throw in here before we kind of move on, when you look at the ASCII table, you'll notice that capital letters have different values than lowercase letters. Okay, so when it's doing this comparison, you have to keep in mind that any capital letter is automatically going to be less than any lowercase letter. So in other words, if I'm looking at capital A compared to lowercase a, and I do something like string S1 equals capital A apple and string S2 is lowercase a apple, then S1 dot compare to S2 is going to be 65 minus 97, the first minus the parameter. So I'm going to get negative 32, even though they're the same word. And if I do S2 dot compare to S1, I'm going to get 97 minus 65 equals 32. So we have to be careful about capitalization when we're using compare to. Okay.
They're all 32, by the way.
They are all 32. Yeah, there's
So
if you notice the difference.
It's one of the binary. It's either on or off, whichever binary. What, 2 to the 5th or something?
Oh, yeah.
Yeah. So if you look at the binary sequence, they're all off by that one. Fun fact, number 2 for today.
Very cool.
Yeah.
If by some chance I set, there we go. If I look at like capital T versus lowercase a, even though T comes after A in the alphabet, capitals always end up less than lowercase. So for example, if I do string S1 equals tomato, which it is a fruit, and string S2 equals apple, but tomato is capitalized and apple isn't, again, keep in mind that it's going to be looking at the values that are associated with those characters on the ASCII table. So 84 minus 97, even though T comes after A, it's still going to give me a negative value. And if I switch, I'll get a positive value. So be careful about that. Okay, we'll go back and we'll review that a little bit when we get to the summary at the end. We'll summarize the high points. Okay, so here's our check for understanding. I want you to take a couple seconds and look at this code. We've got Finnegan, Casey, Mitten, and Tootsie again. We've got some extra strings where maybe we're declaring some things in a different way. And then we're going to walk through all of the system.out.println lines so that you have a chance to tell me whether it's going to return, whether they'll return true or false, or in the case of the compare to, will it give me a positive value, negative value, or 0? Okay, so take a couple seconds and look those over. I'll give you about a minute or so, and then we'll kind of step through these. Okay, about 10 more seconds. Okay, so let's start looking them through. Let's look at our first system.out.println. We want to know what's going to happen if I say S1 equal S5. Okay, so I wish there was some way I could have you do like a thumbs up or a thumbs down or something. This seems really odd as a teacher to go through these and not get some kind of feedback from you. That's weird. Okay, so assuming that you're all giving me a thumbs up, the answer to this one is going to be true. We declare a literal variable, a string literal S1 Finnegan. And then when I come down and do S5, what I'm really saying is to take whatever value is in that bucket, whatever the memory address is that's referring to Finnegan, and copy that exact same memory address to S5. So you can almost envision two buckets, S1 and S5, that have the exact same memory address pointing at the same spot in our string pool. So that's true. What's going to happen when I say S1 dot equals S5? True or false? Well, because S1 and S5 have memory addresses that point at the same object, I'm really saying, the equivalent of it is this pink pen the same as this pink pen. I have one pink pen. Well, in this case, I have one string that's Finnegan. I just have two buckets that are pointing at the same string. So technically, yes, they have to be the same because really there's only one string there to begin with. Okay, if I say system.out.println S3 equals S6, okay, well, again, I have Mitten for S3. I'm taking the reference variable for Mitten, and I'm telling it to copy that same address to S6. So in this case, yes, that's true. What happens if I do S3 equal S7? I have S3 equal to Mitten. I have S7 equal to a new string object Mitten. Okay, so for this one, I have one variable that's referring to Mitten in the string pool. I have a totally different variable that's referring to a totally separate object that I've told to be in a different spot. And because equals asking if the contents of the bucket are the same, that one's going to be false. In this case, Mitten does not equal Mitten. All right, what about S3 dot equals S6? I probably shouldn't have even put that example on there because it's really the same as what we just did with S1 dot equals S5. So yes, that one is going to be true. And if I do S3 dot equals S7, okay, well, again, remember dot equals is the one that does a character by character comparison. So M and M, I and I, T and T, T and T, E and E, N and N. So yes, those strings are equivalent. So that'll be true. All right. What about our compare to? What if I compare Casey to Tootsie? S2 dot compare to S8. So again, we don't necessarily have to worry about whether or not the number is going to be, or specifically what the number is. All we have to know really for our purposes in AP Computer Science A is whether or not this is going to give me a negative number, a positive number, or zero. Okay, so in this case, we will get a negative number. And it just so happens that that negative number is going to be negative 17, the distance between C and T in the alphabet. All right. And we didn't really do an example like this one. What happens if I do S3 dot compare to S7? What happens if I do compare to and I have the same string? Well, in this case, the distance between mitten and mitten in the dictionary, or the distance between M and M in the alphabet, is going to be 0. So we could actually use compare to see if two strings are the same. If I use S3 dot compare to S7 and I get 0, they're the same string. It's no different than if I say dot equals and I get a true. If I say S3 dot compare to S7 and I get something other than 0, doesn't really matter whether it's positive or negative if all I'm trying to do is find out if they're different. If I get anything other than 0, then they're not the same string. So there we go.
Loved it.
Hope everybody got them. Okay, so here's our debrief and summary. For string comparisons, okay, first thing and foremost, I don't know why it's jumping ahead. It keeps skipping on me. Equal equal will not tell you if two strings are equivalent. That is not what equal equal does. That it's not its job, okay? Equal equal will tell you if two variables refer to the same string, okay? And there's a big difference between saying the two strings are the same and saying that the two variables refer to the same string. Dot equals will tell you if two strings are equivalent. That's its job. That's what it does, okay? If given two strings of the same case, in other words, if I have two uppercase strings or two lowercase strings, str1 dot compare to str2 will return a negative number if str1 is alphabetically before str2. And it'll return a positive number if str1 is alphabetically after str2. So that's, again, something you have to kind of work through a little bit, maybe commit that to memory, but it helps to understand where those values are coming from. All right, and if by some chance I'm given two strings where one of them is uppercase and one is lowercase, str1 dot compare to str2 will return a negative number if str1 is uppercase and str2 is lowercase. And it'll return a positive number if if str1 is lowercase and str2 is uppercase. Okay, so again, be careful about that. One of the things that Mrs. Westerlund referred to early on when we were talking about string methods is all of the string methods that are out there that are not part of the AP subset, and we have equals ignore case, there's a compare to ignore case. There are other methods out there that we can use that are not part of the subset. You just, again, have to be careful how you use them. So that might be one way to deal with worrying about uppercase strings and lowercase strings if I'm dealing with compare to. But again, as far as the AP subset's concerned, this is really as far as you need to go. This is the kind of the important stuff from an AP standpoint. So all right, there we go. I'm going to pass things back over to you for our CSA exam tip of the day. Thank you.
Yes, the tip of the day is not so fun and fuzzy on a Friday. It's actually lots of work. I'm going to grab the screen maybe. Go one more slide and then I'll grab the screen.
Oh, there we go.
And there we go. Okay, so other than the cute monkey with his binoculars, that's about the only cuteness on this slide. What I wanted you to do is I wanted to give you a list of a lot of really good free response questions. And I have the 3 that we've looked at this week in a little smaller font. And then I added, I don't know, what are there, 7 more that we didn't look at that have specific things. Today, we were discussing earlier by text message. Let's see. Oh, will you mind unsharing? And then I'm going to share.
Oh, yep, I can do that.
Yeah.
There you go.
Anyway, let's see here. There we go. So it might just be me. Is that what it is? I don't know. No?
Wrong
What am I
window.
sharing?
You're sharing, but it's not. It's
not that. It's just something. I
you're
don't know how
sharing
to
a
do
window,
that.
but I don't think it is what you think that it is.
Okay.
There's my quote again.
There we go. I don't know if I know how to do that actually, to just be me on the screen. I did it the other day, didn't I?
Well, I think if you just unshare, because we're not sharing anything, it'll just
Stop
be
share. How about that?
there. You go. Yeah,
Oh,
that'll do
that
it.
might be too much. But anyway, okay. So what I did today for y'all is I took the slide with I'm gonna call him George, and I wrote down. Y'all's do not have all the little Jill notes in them, but I with the bold Sharpie marker, I took these 10 numbers and I made you a PDF version of this page. And what I would love for y'all to do is do an analysis of these questions. And the point is, if you can see from mine, I'll kind of scoot it really close. And then I'm going to give you some tips. I tried to look up like what is it backwards or is it normal?
No, I can see it normal.
Oh, good. Okay.
Yeah, you're good.
So I tried to write down like what you might use to solve that problem. It doesn't mean that's exactly what you would have to use, but it's what I felt like you would use. You could study the prompt. You need to probably look at the canonical answer. But you need to look at these questions. Now, when I was going through them, if you'll notice, I did highlighter. I hope you can see it around this one. 2006, number 3 would be the best weekend homework to follow up our week that you could probably do. If you'll notice from this one, it has lots of the methods that we've talked about, and it also uses a few different arrays in the question. Not array lists, but arrays. Many of these others involve array lists, which is what we're going to next week. But like this question, I thought was like gold star if I had one to put on it. The other ones that I really, really liked when I was looking at them were these two. What is that? 2016 number 2 and 2014 number 1. They were really they used a variety of string methods that we've talked about this week. The ones I didn't think were probably the best to look at this week were these two, 2008 number 2 and 2007 number 3. They're great questions, but they both involve array list, and we're going to work on that next week. So maybe look at those, but don't spend a lot of time actually coming up with a solution for those. But my tip for the weekend is 2006 number 3, and then those two that I underlined in gold and yellow. So this is what I would love for y'all to have. You're going to have, lots of weeks, several before the AP exam, and I'll probably give you another one of these next week now that we've done this for array list, and then we'll do another one for I'll go back and make y'all one for arrays as well so that you can have those. And so now you grab it back, if you don't mind.
Got it.
And show us what Finnegan and all these cute names. We got to put a face with a name.
Oh, yeah.
Yeah, and the homework is the homework. So y'all look at your power up, and it involves what I just showed you.
Okay, there we go. All right,
Yeah.
so here we go. Here's Finnegan and Casey and Mitten and Tootsie and the stars of today's lesson. So
yeah, we didn't know Tootsie was a turtle.
Kind of a surprise.
Super cute.
A red-eared slider. I don't think I've ever seen a red-eared slider before.
I know, and I like how he's looking, or she's turning her face, and we see the red ear. Super fun.
Most of the turtles that I grew up near a river, and we would go looking for turtles, but we would find like painted turtles and box turtles and
oh, and I think I misspelled Toronto. Sorry.
Ooh,
that's definitely not.
Oops,
that's
Tarata?
How my grandmother would have pronounced it.
Tarata?
But that's not how it's spelled. Yeah. My grandmother would have said it that way.
Well, again, keep the pictures of your pets coming. We love seeing your pets.
Please, please. And again, cb.org/tech if you have a tech need. And thanks for watching.
Yep.
Have a great weekend.
Everybody have a great weekend, and we'll see you next week for array lists.